stuff done. It's already, we only have 50 minutes left. So, what I'm going to do from now on, when I do the book problems, I'm going to work out fewer of the more complicated ones for the book problems and do those on the board with this video. So this is what I propose, that I will publish a video on book problems that is essentially a converted PowerPoint with all the book problems and the answers, and I animate it myself in an old-fashioned manner. And then what I'll do is I'll make these kinds of videos as a support of the book problems, in that the more difficult ones with calculations I'll do on the board. Clear? Such as number 84 on the video. Now, just keep in mind that they're very similar, the text, the online text, and the text we have, because they're just numbered slightly different. Clear? Yes? So on the video it's number 84, and in the book it's 86. Okay, let's do it. Okay, so read to me number 84 from the book, 86 from the book, 84 from the video. Go ahead. What is it? Anybody? Anybody hear it? Yes. I need you to say it loudly because I have a fan in my ear that can't be turned down. Go ahead.
2 kilograms sample of bituminous.
All right, 2 kilograms.
Bituminous coal.
All right. It's pronounced like bituminous. Bituminous coal. It's fine. Bituminous coal is what we call soft coal, as opposed to anthracitic coal, which is a harder coal. Okay? So bituminous coal, all right, 2 kilograms of it. Okay, carry on.
It's composed of 1.30 kilograms of carbon.
All right, wait a second. So they're doing an analysis of the bituminous coal, and they're finding, what are they finding?
It's composed of 1.30 kilograms of carbon.
So it has 1.3 kilograms of carbon. What else does it have? Does it say?
0.20 kilograms ash.
0.20 ash. Okay, carry on. And that's kilograms, right?
Yeah.
What else?
0.50 kilograms of water.
All right, 0.50 kilograms water.
And 0.35 kilograms of volatile.
35 kilograms of volatile gases or whatever, gases or things that make a gas. Yes? Okay, now, I just want to do an on the side thing. Can I do an on the side thing? This is really off topic, but strangely related. Is that okay? You'll notice that sometimes I'll go like this. Sometimes I'll put a 0 here, sometimes I won't. Okay? Is that confusing? You see, let me tell you a little story to my knowledge. I may be dead wrong. And if I'm dead wrong, tell me. When I was in 3rd grade, we had something called New Math. That was mid-60s. And in New Math, that was where we changed from writing decimals like this to decimals like this. So I was at the border of the change. People who were born, I was born in 1955 and I was in 3rd grade in approximately 1965-ish, okay? So anybody who was born before 1955, 2 or 3 years before then, wrote decimals like this. People who were born after 1955 write them like this. And most people nowadays, the older people now, my age, younger, we write them like this, but we also write them like this a little bit. But this is the main way. How many people mainly write decimals like their math teachers, like this? Raise your hand. Yeah, most people are raising their hand. The other people are, their brains are wandering the hallways, okay? Make sure your brain has a pass if it's wandering the hallway, please. Alex, is that okay? Okay, good. He's shaking his head. He thinks I'm crazy. That's okay. Okay. But, so, it's a new math thing. So, in terms of significant figures or not significant, it's not even a place value holder. It is just formatting. You know, if a 0 is not significant, it's a placeholder. Remember hearing that? Right? Well, this is just, nowadays we would call that a format. A formatting 0. It means absolutely nothing. They say it's to be able to know there's a decimal place there more easily. Because if I have this, you think, well, maybe it's 35. But if I start with a 0, I know that there's a decimal there. But it has absolutely no meaning whatsoever. It's part of the new math, that the new math died a very, very tragic young death. Okay? All right. Just wanted to clear the air. Because I can see people like wondering, why is he doing that? Sometimes he has a 0, sometimes not. All right, so what's the actual question? We know that the bituminous coal has approximately this analysis. Okay, which is about right. That actually would equal approximately 0.7. Yeah, or more than that actually. Yeah, a little more. I don't know where they get it all. Did you forget some zeros maybe? No, that's what it says. That's what it says. Okay, anyway, it doesn't matter. So, is that 0.35 or 0.15? Yes?
Water is 0.15.
What's this?
0.15.
Okay, that helps a lot. Thank you. That helps a lot. That you may have said that, I just didn't hear it correctly. Okay, so the question is, it says, determine how many kilograms of carbon are in 125 kilograms of this coal. Okay? So this is the way I would do it. And I'm going to show you this way, and I'm going to tell you why I'm going to show you this way. And this is big. This is real big. Okay? This is big. This is the biggest thing I've said to you in a few days. Are you ready? This is big. Big, 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 big. Okay. If you do problems, Alex, right? Your name is Alex, right? Your first name is Alex? Mr. Paz? What's your first name? Alex. Okay, well, I'm speaking to you, right? So I need some, is it glasses? Is that what it is? Excellent. Now, if you do a problem with a lot of factors of one equivalent, where you're doing this dimensional analysis with all of these steps, what happens is that you lose the sense of what it is you're actually doing. If I'm finding the density of something and I keep changing the units from cubic meters to cubic centimeters, from grams to kilograms, from grams to pounds, whatever it is I'm doing, if I'm doing all of these multiple steps, you're going to lose the sight of the science. The science is the density of something. The physics, the characteristic physical property. Our book calls it an intensive physical property. An intensive physical property is not dependent on quantity, but the quality of matter, what it is actually made of. The density of a small grain of gold has the same density as a giant bar of gold. Clear? However, if I take this tissue and I find the mass of it and then rip it apart, it's going to have a different mass. That changes, right? So mass, length, that's dependent upon the quantity of matter. So when we're studying intensive physical properties, I think a better way to describe it is a characteristic physical property. The more you The more dimensional analysis you apply to a problem, the less you're going to understand the science involved. Clear? So let me do this in a way, in a fashion that I do relative to something we're going to study called stoichiometry. And I don't like dimensional analysis with stoichiometry because in stoichiometry you lose the whole concept, and it is the central thesis of any calculation within chemistry is stoichiometry. It's a technique, it's an idea, and you lose sight of that if you do all these dimensional analysis steps. So let's do something simple like 7th grade math, and we're going to set a proportional relationship. Clear? How much coal can I get out of 2 kilograms? How much coal can I get out of 2 kilograms? 1.3 kilograms, is that correct? Is that correct? You guys are looking at me like I'm crazy. Are you guys going to participate? Yes or no? How much can you get out of 2 kilograms of coal? Tell me. I can't hear you. You're like this. How much? 1.3 kilograms. So isn't there a proportional relationship that you could write? What would it be? We're so sleepy this morning, I have no idea. It's like a brain trauma recovery ward. They're suffering from brain trauma and they're just starting to be able to learn. Laura, you want to help us out here? Is there a relationship that I can draw, a proportional relationship that will help give me the answer? Shall I say it out loud and then maybe you can write it down? Is that okay? Yes? 2 kilograms gives me 1.3 kilograms of coal. 125 kilograms gives me how much? There's a proportional relationship in there, isn't it? Yes? Well, carbon, yes, I mean carbon. Was that what I was confusing? Yeah, well, yes, I'm sorry. Carbon. I apologize. Was that confusing everybody? Oh, okay. Carbon. How much? I can get 1.3 kilograms of carbon out of 2 kilograms of coal. How much carbon can I get out of 125 kilograms? Write that down. Write that mathematical relationship down. Can you do that? You, young lady, have extra credit for correcting me. I like that. One of the shyest people in the class can correct me. And you're not shy. I'm not telling you. You're going to tell me. I already gave you too much information. Okay? I'm being rotten, I know. Ugh. Mr. Darcy is such a jerk. Shall I say the question again? Okay. Okay. I can obtain 1.3 kilograms of carbon from 2 kilograms of coal. 1.3 kilograms of carbon per 2 kilograms of coal, correct? How much carbon per 125 kilograms of coal? What would I do? Can you do that mathematically? Do we have to get a middle school math teacher in here to help you? Am I being horrid? Shall we write it down very quickly? Okay. 2 I'm going to erase some of this so you can see it. Does that make sense? Have you seen something like that before? Please raise your hand. Oh my God, they're all raising their hand. They're actually listening to me. Excellent. Are the minds coming back? Are you reconnecting? Okay, excellent. Thank you. Thank you, sir. Thank you. So, how would you solve for X? How would you solve for X? Yes?
Divide 125 by 2 and multiply by 130.
Yeah. I like to say it a little bit different. It's easier to remember, but that's not incorrect. Okay? cross multiply, and divide. Okay? Yes? So this is cross multiply and divide. Okay? So in other words, A over B equals C over D, correct? If I'm solving for D, I cross multiply and divide. Clear? Yes? If I set it up like A over B equals C over D, let's set it up differently. Can you calculate that? Do you have an answer for me? Yes? Okay. Hold your answer. Write it down. Okay? Now I'm going to, may I leave off the unit labels just for clarity and seeing the numbers? Is that okay? Laura? It's okay? Say yes. Thank you. Okay? All right. So let's say 1.3 is to 2 as x is to 125. So now I'm solving, it's in the C position. Will I get the same answer?
Yes.
Will I get the same answer, Baslin? No? I won't get the same answer? This is a problem. Okay? If you cross multiply and then divide, you will get the same answer. Do you have a calculator with you, Baslin? Okay, why don't you calculate this and we'll compare it with the former. Understood? Okay? What do you get in the first way we do it? What do you get for x?
81.25.
81.25 kilograms. We'll ignore significant figures for the time being. Is that okay? We are doing significant figure suspension for the remainder of the period. Is that okay? All right. What did you get when you did it this way? What's 1.3 times 125 divided by 2? Anybody? What is it? You could fake it and say this number and it's right. Did anybody do this? What did you get? 81.25. That is basically the math of chemistry. I mean, there are certainly differences. You know, there's some additional things you have to know, obviously, but that's a major math. If you can't do that math, we've got to fix that, okay? We've got to really fix it. Because by November, we're going to be heavy duty into stoichiometry. And if you can't do this math, simple math, your brain is going to explode and you'll make a complete mess. Okay? We do not want any exploding brains, okay? Yes? All right. Yes, we're finished. Can we stop? We'll do another one. This video was very all over the place, okay? But it was good. It's all right, okay?